Projectile motion. As we know that the projectile motion is one type of the curvilinear motion, but when we have a projectile motion, we can resolve it in the two components along the x and y direction, and the motion for each component is independent to another elements or another components. Let's look at this example. A projectile is fired from the edge of a 150 cliff with the initial velocity of 180 meters at the angle of 30 degrees with the horizontal. Neglect the air resistance. Find the horizontal distance from the gun to the point where the projectile strikes the ground. Is meaning we have to find this x. And the next one is find the greatest elevation above the ground that the projectile reaches. As you can see, the initial velocity is 180 meters per second, and the degree with the horizontal is 30 degrees. For solving this problem, the projectile motion, you can set up your origin in any arbitrary point. But the important thing, when you are trying to answer any part, always you have to look at your setup of the origin. Okay, for this problem, I set up my origin in the above the cliff. Okay, this is the cliff. Okay, is 150 above the ground. Okay, and this is the projectile. The initial velocity is 180 meters per second, and the problem mentioned is the angle with the horizontal direction is 30 degrees. So first we have to resolve the velocity along the x and y, the vx and the vy. The velocity along the x-axis is 180 times cosine 30 degrees. So the answer of the velocity along the x direction is 155.9 meters per second. And the velocity along the y-axis is 180 sine 30 degrees, and the answer is 90 meters per second. Okay, for the first part we have to find the x. Okay, so for this reason we are applying the horizontal motions. Okay, what is the equation for the horizontal motion? The x equal v0 t along the x direction plus initial position. Okay, so we can say x equal the initial velocity along the x direction is 155.9 meters per second times t plus what is the initial position. If I set up my origin here, okay, we can say the initial position is 0. Okay, so based on this equation, the position of the particle along the horizontal motion is 155.9 t. We are looking for x, but as you can see, we don't have any information about the time. For this reason, for finding the time of the projectile motion when the projectile hit the ground, we have to find the horizontal distance. Okay, for the horizontal distance, we know that the equation is follow this equation. The y equals minus 1/2 gt squared plus v0 times t. Okay, the initial velocity along the y-axis plus initial position. Based on our setup, the initial position is 0. And we are solving this problem in the SI system, and the J, or the gravity, is 9.81 meter per second square t square, plus initial velocity along the y-axis is 90 times t. Okay, and what is the value of the y? When the projectile is hit the ground, for example this part, can I say the coordinate of the projectile is x and minus 150, because I set up the origin this point. Okay, at the origin point the coordinate of the x and y is 0, 0. But how about this condition? The coordinate of the projectile is become x and minus 150. So we write minus 150 minus 1 half 9.81 t squared plus 90 t. As you can see, we have a quadratic equations. When we solve it, and we can find the roots, okay, and at time 19.91 second, okay, the projectile hit the ground. When we find the time, definitely when we plug to this equation, we can find the x. Okay, so we can say x equal 155.9. What is the time, or the time the projectile hit the ground is 19.91 seconds. So the answer is 3,100 meters. This is the answer of the part A. For the part B, we have to find the maximum of elevation of the projectile above the ground. Again, this is the cliff, this is the initial position, and this is our setup of the origin. Okay, this is 150. We have to find the maximum of the elevation. Can we say the maximum of the elevation is happen when the velocity along the y-axis is become 0? Yes. Okay, because if you remember, for the based on the three basic kinematic equation, this is position, s, y, x, no matter. Okay, this is velocity, this is acceleration. Okay, if we are looking for maximum of the position, the maximum of the position is happen when the velocity as a 0, and when we are looking for a maximum of the velocity, the maximum of the velocity is happen when the acceleration is 0. And we know that the maximum of elevation, okay, for the projectile motion is happen when the Vy is become 0, because for the x component always we have a constant velocity. So if I apply this equation, the Vy is minus gt plus V0y. Vy minus 9.81 times t plus initial velocity along the y-axis is 90 meter per second. So the maximum elevation is happen when the velocity is 0. Okay, and when we solve this one, the time is 9.18 seconds. Okay, then we have to plug this in, we have to plug the time to the equation of the motion along the y-axis. What is the equation of the y-axis? Y equals minus 1 half gt squared plus V0y is a 90 times t. How about the initial position along the y-axis is 0 because we set up our origin here. So the y is minus 1/2 9.81. The time is 9.18 square plus 90 times. Okay, the answer is 412.7, or we can say approximately is 413 meter. But look at this one, 413 meter above our origin, but the problem asks us to find the maximum elevation above the ground. Okay, for these conditions we have to add the 150 that we can find the maximum elevation above the ground. For this reason we can say the maximum of elevation above the ground is 115 plus 413 is 563 meter. For the part B, also we can apply the third basic kinematic equation, is meaning this equation. The v square minus v0 square equal 2g delta y. Okay, so what is the velocity of the projectile at this point? At the maximum of the elevation is 0. What is the initial velocity of the projectile in the y direction? Is 90 square, and the gravity is minus 9.81 delta y, or the y, no matter. Okay, when we solve this one, delta y or y is 413 meter. Again, we find this one based on from the origin, but our origin this point above the cliff. So again, for maximum of elevation above the ground is 413 plus 150 is the length of the cliff is 563 meter. As you can see, you can choose one of these solutions, but finally you get a same answer. Thanks for watching.